Okay, we'll start or wait for 1 or 2 minutes. Okay, so we'll start. How long to wait? Okay, so I've done with my work. Whatever I'm supposed to do, 5 chapters is completed, and I'll be starting a revision from the beginning till whichever day we are have a last working day. Okay, so now we start with the revision. So, module 1. So, in this, what we have seen is what are the different types of database and applications. So, databases sometimes we can have a numeric and textual data. So, numeric you can see when you're watching a cricket match, then you may have a numbers in it. So then even along with that, you'll be having who is batting, what is the name of a person who is batting and who is bowling, all those details will be there. But that will be in the textual format. So then you can see that is one example where they'll be keeping in their database, both the numeric and text data. So in the same way, multimedia database. So now you have the channels or TV channels, or you can see your in mobile also. You may watch movies also. So there, then it should be stored somewhere, right? So that's what that type of database is called as a multimedia database. Then you want to visit from one place to another place, and that is a new place, and you don't know the route. Then what you do now, nowadays we have something called as a Google Map. It will show you the routes. So in that case, we have to store a Google Map also. So in that case, we are storing that in a form of geographic information system. So then, not only these, there are so many other applications where we have to store somewhere. So that type of that is also one type. So in the same way, data warehousing. Now, suppose you think that we want to know whether today it is raining, tomorrow it will rain or not. So then the forecast will be there, along with that graphs will be there. So many things will be there. So then we have something called as a data warehousing. Then real time and active database. So your mobile, your WhatsApp is a one best example of active database. So then what active database it is, the small though you have your mobile, even in your mobile also you have a memory or a small database where your WhatsApp will be stored somewhere, images will be stored along with the text, everything we are storing in the WhatsApp. So these are the some types of databases available. So next we move on. What are the basic data type, basic definitions of data? So now data, raw facts that can be recorded or acquired, which has an implicit meaning. Example, age, color, name, etc. So then how do we store your third semester table? I should have your USN, you should have your name, I should have all the subject details. That is required. So then instead of those taking, if I take something else, so if I take your pet name, if I take your friend's name. It is not required for department. Then such type of data is called as a raw data, which is not up according to the facts. But we also have what we have. We have your USN name, all your marks, attendance details, everything we have. So then that is called as a raw data, which is required for us, and it is meaningful and it is required for the department. Then the same way, where we store it in the Excel. Excel is also one small database where we store all in the form of column and rows. So that is a database, a collection of related data organized in a proper manner for effective and efficient storage and retrieval purpose. So that's what your database is. So what we do, efficient storage and retrieval purpose. So what we do here, we store. So we store your USN first or name. Who asked us to store first USN? Why don't we store it your name? Yes, it is left to us, but it is still meaningful. It has a efficient way of extracting our data. So for this, what we do, Access is there, Excel is there, Access is there. So like that, we have so many database applications or softwares available. So that's what here, database management system. How do we just speak about the system, how it is working? A software or a package or a system to facilitate the creation and maintenance of the computerized database. So then how all these, that is what a database management system will be doing. Then mini world. So database problem statement, some part of the real world about which data is stored in the database. For example, student grades and transaction at the university. So that mini world. So now take an example. Now mini world is like your university. If you know your USN number, you can fetch all your marks cards. So in case if you have lost any marks card, you can fetch them. So that is what is a mini world or a database problem statement. Some parts of the real world about which data is stored in the database. For example, student grades and transaction at the university. So then typical DBMS functionalities. What are the functionalities available for a DBMS? We define a database. So that is main important thing where we define our database in terms of data type, structures, and constraints. So then we have a construct or load the database on a secondary storage medium. So then manipulate the database, querying, generating reports, insertion, deletion, and modification to its content. So then concurrent processing and sharing by a set of users and programs, yet keeping all data valid and consistent. That is what we see with respect to typical DBMS functionality. One is define a database. How do we define what is a data type, what is a structure, what is the constraints, what are the values we have to store. That's what is a define a database. Then construct or load the database on a secondary storage medium. So that's what here, construct or load the database on a secondary storage medium. That's what we see about loading. Then manipulate the database, querying, generating reports, insertion, deletion, and modification to its content. Then concurrent processing and sharing by a set of users and programs, yet keeping all data valid and consistent. So that's what here is typically DBMS functionalities are. So define a database, construct and load the database, manipulate the database, and concurrent processing and sharing by the set of users. So what are the other features typically we have in the DBMS functionality? Protection or security measures to prevent unauthorized access. Active or processing to take internal action on data. Presentation and visualization of data. So examples of a database with a conceptual data model, mini world for the example, part of the university environment. Some mini world entities like student, course, section, department, and instructor. This is one small example where in the mini world, we have taken an example of university. In university, how many tables we may require? Just think about university database. How many tables is required? What are the table names we have to give? What are the column names we have to give? All these we have to think before we start doing any project. So that's what here because you are already familiar with university, then you will be knowing what is required for university. Then definitely, if we say university, there we have a student, then we have a courses, then we have a section, then we have a departments, then we have a instructor. So that's what here conceptual world will be doing. That is some mini world entities, that is students, course, section, department and instructor. So note the above could be expressed in the entity relationship data model. So the same thing can be expressed in the form of entity relationship model. So next is database system environment. What is the environment for the database system? So here we have database system. So the database system software together with the data itself, sometimes the applications are also included. So let us see how this database environment. So in this application program, so now you write some small application program to collect all the details. So that is also fine. Then we call that as an application program. Then database software, what type of backend you are using? SQL, MySQL, Access, Excel. There are so many things. So then you may use any one. Then that is what is called as a DBMS software. Okay, we have software, but we have to store somewhere, right? Where we'll be storing? We'll be storing in a hard disk. So initially, when we are working, it will be present in a ROM. Then later, it will be shifted back to the hard disk. That's what the stored data is required. So that's what here the architectural diagram for this is. First is database system, in that DBMS software, then metadata. So now you use a create. So create a table name, column names with data type, all those you do. So then where that will be stored? That will be stored in a metadata. So when you store insert values into the table, that will be stored in a stored database. So that's how two different definition is stored in one place and table is stored in some other place. That's how here linked between these two. Then we use the softwares. Now in our lab, we are using a SQL. So in the SQL, so what we are using, we are trying to execute the program. Software to process queries and programs. Software to access stored data. So then database system, application programs or queries. So that is what is a database system is. So then example of database with a conceptual data model, some mini world relationship, sections are of specific courses, students take sections, courses have prerequisite courses, instructors teach sections, courses are offered by department, students major in the department. The above could be expressed in the entity relationship model. So then what are the main characteristics of the database approach? So then self-describing nature of the database system. A DBMS catalog stores the description of the database. The description is called as a metadata. This allows the DBMS software to work with a different database. One second. Okay, so self-describing nature of the database. So when we say 1BY19 MCA01, so what it is describing to you? So it is describing as 1 means what? Which region it is. It is a Bangalore region. What is BY stands for? Which college they are studying. So that's why BY. And which year they have joined the MC course 19. What course they have joined MC. What is the number? 01. Like this, it is self-describing. If you go and ask in the university, they will definitely identify from which college you are and which branch you are. So everything it is to be noted. That's how the number USN has come into existence. Self-describing nature of the database. A DBMS catalog stores the description of the database. The description is called metadata. This allows the DBMS software to work with different databases. Insulation between programs and data, called program data independence, allows changing data storage structure and operations without having to change the DBMS access program. So then in the same way, how do we insulate between the program and data, how the program is working and how the data is being, how to fetch them. That's what you'll be knowing, call by reference, call by value. So that is with respect to program. But in the same way here, what we are doing, we are calling data from the database to the any front end thing. That is a program. So program, then you should know how we have to access the program and the data. So next we have data abstraction. So now if you go for the banking sector, how the database definitely will be very huge, because there will be so many accounts in the database. Can we view all the database? No. What we can view, we can only see our uh, account details. We cannot see other persons, though he is your friend, but still you cannot see the other details. That is what is called as a data abstraction. Data abstraction means what you want, only that will be shown to you. A data model is used to hide storage details and present the users with a conceptual view of the database. That is what is called as a data abstraction. So then we have a support of multiple views of the data. So now the same thing I told in the banking, I can view only my account. But in the same way, you go and ask in the banking person who is employee in the bank, then he can at least have his own different view, not same as our view. What we can see only our account. But whereas if you go and ask the banking person, he will be seeing in some other different way. So in the same way, the same thing, you can go and ask the developer who has developed the application. Then he will be having his own view. So this is how the different views are there for each people. So each user may see a different views of the database, which describes only the data of interest to that user. So the main characteristics of database approach, a sharing of data and multi-user transaction processing. So the main characteristics of database approach, sharing of data. So now you people are sharing. So what we are doing, we are using a GCR, Google Classroom. So then what we are doing, we are sharing PPTs, notes, question papers, assignments, everything in the GCR. What is that? That is a sharing of data. I cannot send, I want to send for all 50 of you, just I'll send it in the GCR, because even you people have the access to all, you can see all the data. That's what is a sharing of data. And multi-user transaction processing, each of you. So now we have started conducting internal exam. Then what we have done, we have sent you question paper and we gave you some time. Then how many of you, I have sent only one question paper, but how many answer scripts I'll receive back? All 50 I will receive back the answer sheets. Then what it is a multi-user. So our transactions, what we are doing, we are using a multi-user transaction processing, allowing a set of concurrent users to retrieve and to update the database. Concurrency control within the DBMS guarantees that each transaction is correctly executed or completely aborted. So what is this concurrency control is been doing? So concurrency control, so it is checking with the DBMS that guarantees that each transaction is correctly executed and correctly executed your this. So sharing of data and multi-user transaction processing, allowing a set of concurrent users to retrieve and to update the database. Concurrency control within the DBMS guarantees that each transaction is correctly executed or completely aborted. So what is this? Transaction processing or concurrency control will be done. Concurrency control within the DBMS guarantees that each transaction is correctly executed or completely aborted. So online transaction processing, OLTP, is a major part of database applications. Database users may be divided into those who actually use and control the content, called actors on the scene, and those who enable the database to be developed and the DBMS software to be designed and implemented, called workers behind the scene. So we have who are the database users. There are huge number of database users. How the database users are, that's what here you can see with respect to same WhatsApp. we are creating a groups and we are using it. So sometimes we may create a same WhatsApp group only where the admin can put the message and we cannot interact. There are different ways of creating like that. In the same way, database users, how many database users are there? So the people who are on the screen and the people who are behind the screen. Now we are just using WhatsApp, but can you imagine who has developed that and how much they would have thought about doing a WhatsApp? So that's what user may be divided into those who actually use and control the content called actors on the scene, and those who enables the database to be developed and the DBMS software to be designed and implemented, called workers behind the scene. The database user, actors on the scene, database administrator responsible for authorizing access to the database. So who is database administrator? He is responsible for authorizing access to the database, for coordinating and monitoring its use, acquiring software and hardware resources, controlling its use and monitoring efficiency of operations. Then database designer, responsible to define the content, the structure, constraints, and functions or transaction against the database. They must communicate with the end user and understand their needs. Then who is the end user? We are the end users. They use their data for querying, report, and some of them actually update the database content. So then categories of end user: casually access a database occasionally when needed. Navy or parametric, they make up a large section of the end user population. They use previously well-defined functions in the form of CAN transaction against the database. Examples are bank teller or reservation clerk who do this activity for an entire shift of operation. So that's how here, what are the different types of end user? Maybe sometimes casual users. Maybe you can see some logins we use very rarely. So such type of database we call it as a casual user. Then Navy or parametric user, we so now WhatsApp every day we are using, every hour we are using. So in the same way, if third semester MCA group is created and every 1 hour, one staff will be asking you to join. So what is that type of database? Every day, every hour we are interacting with that database. That's what is a Navy or parametric. They make up a large section of the end user population. They use previously well-defined functions in the form of CAN transactions against the database. Examples are bank tellers or reservation clerks who do this activity for the entire shift of operation. Then categories of end user, sophisticated. These include business analyst, scientist, engineers, others thoroughly familiarly with the system capability, may use tools in the form of software package that work closely with the stored database. So standalone mostly maintain personal database using ready to use package application. An example in an tax program user that creates his or her own internal database. That is what a sophisticated and a standalone. Advantage of using the database approach: controlling redundancy in the database storage and in development and maintenance efforts, sharing of data among multiple users, restricting unauthorized access to the data, providing persistent storage for program object, so providing storage structure for efficient query processing. So these are some of the advantages of database approach. What are the advantages we have? So some more advantages of database approach: providing backup and recovery. The same way you can see your mobiles, because mobile phones, maybe 2 years once, 3 years once, we keep changing the mobile phones because we get high-end and we want the high-end phones. Then think of the contacts in the phone. We have to keep it a backup. So then how to keep the backup? So that's what we will link everything with our account so that the backup will be stored there and we can recover at any time. So then providing multiple interface to a different classes of user. So what are the different interfaces we have for the each user? So that's what I just told. In banking, each has their own interface. As a bank employee will be having different interface. Supporting team will be having different interface. We as an end user using the banking application will be of a different interface. That's how here different interfaces are used for different people. Representing complex relationship among data, then enforcing integrity constraints on the database, drawing inference and actions using rules. Additional implications of using a database approach. Potential for enforcing standards. This is very crucial for the success of database application. In large organizations, standards refer to data item names, display formats, screens, report structure, metadata. So then reduced application development time, incremental time to add each new application is reduced. Additional implications of using the database approach: flexibility to change data structure. Database structure may evolve as new requirement as defined. Availability of up-to-date information, very important for online transaction system such as airline, hotel, a car reservation. So this is how the additional implications of using a database approach. So then economies of scale: by consolidating data and application across departments, wasteful overlap of resources and personals can be avoided. Then history of the database, when it was started, what was the different applications, what was the initial database, we see them. So historical development of database technology, early database applications. Earlier it was in 1960s, they were using only hierarchical and network model. And it was introduced in the year 1960 and dominated during 70s. So even in 60s and 70s, these two models were there, hierarchical and network model. A bulk of worldwide database processing still occurs using these models. Still, even today also, they are using this hierarchical and network models. Then next is relational model database. The model that was originally introduced in 1970s was heavily researched and experimented with IBM and the universities. Relational DBMS products emerged in 1980s. So before it was only hierarchical and network. So later in 1980s, relational model. What is the relationship between this column and that column? That's what here right now we are seeing. So later on in 1990s, object-oriented application as C++, Java, all these have emerged. So in that case, even they thought of having a database with where can we use our object-oriented applications in the DBMS. That's what the idea in the 1990s, to cater to the needs of complex data processing in CAD. You can see in a CAD applications, very minute things also they have to keep track. So in that case, they were using this object-oriented applications. So in the same way, data on a web and e-commerce applications. Now you can see, because even classes also now what we are doing, we are taking up online classes. So that is what the web. So all data where it is, even you can see all our video recordings are there in your YouTube available. That too in MCA with BMSIT channel we have. So that is what is a web. And e-commerce, you can see your Amazon, Flipkart, all these are the e-commerce application tools where we are using them. So this is one type of database. Web contains data in a HTML form, HTML. So you'll be knowing what is HTML, hypertext markup language, with the links among pages. This has given rise to a new set of applications, and e-commerce is using new standards like XML, that is extended markup language. So then extending the database capabilities, new functionalities is being added to DBMS in the following areas: scientific applications, image storage and management, audio and video data management, data mining, spatial data management, then time series and historical data data management. So these are the new functional capacities where the database can be using. So scientific application, now you can see there are you would have seen so many movies, Mangalya and all these. So if you see that there are so many people who are doing the research or scientists where they want to know what exists in moon. So in that case, how you would have seen even DRDO, how the satellites have they've been released, the Chandrayana 2, all these were there. So that's those in that case, because they have to keep track and take the photos, take audio, video, all the things which are present in the moon. So that in that case, we use a scientific application. So in the same way, image storage and management. So images take more space compared to text and numbers. So in that case, we have to have a image storage place very big, and accessing them is also very difficult. That's what image storage and management. Audio and video data management, so that's what songs, movies, even that should be present in the database. So the storing so many movies also, a huge number of movies should be stored. Then imagine when we have a laptop, how many before, at least 10 years or 15 years down the line, how many movies we were able to store? Maybe not be more than 10 movies we were able to store in our laptops. If I want to store one more, I have to delete the older one. But nowadays, because the capacity of the hard disk has increased tremendously, even we can store huge number of movies. So that's how here audio and video data management. The same way data mining, because every one of us started, at least in this COVID-19 era, everyone started using online. Then imagine how much online transaction, internet is required, all communication is being done through online. So in that case, how much data has to be made, and which data should be saved, which data should be left. So that's what is data mining takes place. In the same way, spatial data management. So now Google Map. So how many people are using Google Map? Exact directions they have to give. Imagine in the world how many people at one particular time will be using Google Map. There will be a huge number of people. That's what here spatial data management. Then time series and historical data management. Time. So now we are scheduling before we were scheduling this every day, every hour, one separate message, separate IDs we were sending. But now what we have done, we have just created one ID where all ID is present in that. You people know only to log in there. So that's what a time series and historical data management. Then when not to use DBMS, when should we not require the DBMS? Main inhibitor, that is cost of using the DBMS. If suppose you think that purchasing the software may be very high, maybe some lakhs together if you want to pay, and your work is very small, maybe not less than 10,000, then investing lakhs together is not fine. So that's what here, when not to use. So high initial investment and possible needs for additional hardware. So that's what additional things we have to add, then it will be very difficult for us to use a DBMS. Overhead for providing generality, security, concurrency control, recovery, and integrity functions. All these are also should be maintained. Generality, everyone should be using the database. Then security, if my account, no one else should see, that is security. Concurrency control, I'll also be using the database. My friends also are using database. Concurrently, I'm using, though, then it should be it should work. That's what concurrency control. Recovery, if something goes wrong, it has to go back to the earlier stage, that is recovery. Integrity, so if 10 people are using, still the database should work fine. That is what is the integrity. Then when a DBMS may be unnecessary, if the database and the applications are simple, well defined and not expected to change. If there are stringent real-time requirements that may not meet because of DBMS overhead. If access to the data by multiple users is not required, that is what when the DBMS may not be unnecessary. When no DBMS may suffix if the database system is not able to handle the complexity of data because of modeling limitations, if the database users need special operations not supported by the DBMS. Next, we move on to a data models. So data model, a set of components, set of concepts to describe the structure of the database and certain constraints that the database should obey. Data model operations, operations for specifying database retrieval and updates by referring to the concept of data model. Operations on the data model may include basic operations and user-defined operations. That is what is a data model operation is. Categories of data model, conceptual or a high-level model or a semantics. Data model provide concepts that are close to the way many users perceive data, also called entity-based or object-based data model. Then physical or a low-level or internal data model provide concepts that describe details of how data is stored in the computer. Implementation or representational one, data models provide concepts that fall between the above two, balancing user views with some computer storage details. History of data model, relational model proposed in 1970s by EF Code, that is IBM, first commercial system in 1981 to 88. Now is several commercial products, that is DB2, Oracle, SQL Server, Sybase, Informix, all these are the relational model. Next, we have something called as a network model. The first one is to be implemented by Honeywell in 1964 to 65 IDS system, adopted heavily due to the support of Codacil. DBTG report of 1971, later implemented in a large variety of systems. So IDVMS, Cullet, now it is called as a CA. Then DMS 1100, now we are calling it as a Unisys. Then image was called, and now we are calling it as a HP. VAX DBMS, that is Digital Equipment Corporation. These are the network models where each company was developed. Then hierarchical model implemented in a joint effort by IBM and North American or Rockwell around 1965 resulted in the IMS family of system. The most popular model, other system based on this model system, 2K, SASC Inc. So then history of data model, object-oriented data model. Several models have been proposed for implementing in a database system. One set comprises a model of persistent OO programming languages such as C++. That is object store or persistent and Smalltalk. Example, we have a gemstone. Additional systems like O2, Orion, all these are the additional one. And they were called by a MCC, then it was called as a ITAXI. In the same way, Iris at HP people used an open database connectivity. Then one more model, that is object relational model. Most recent trend started with the Informix Universal Server, exemplified in the latest version of Oracle, that is 10i. Now you can see that we have more version of Oracle. So it was 10G earlier, 10i. Later it was 10G. Now you can see still higher end versions are available for Oracle. So in the same way, DB2 and SQL Server, etc. So I'll stop here. We can continue this in the next class. And people who have joined late can complete your quiz. I've pasted in a chat window. You people can complete the quiz. Asta, answer your attendance. Asta,
Yes, ma'am.
last class.
No, ma'am.
Abhinav, Aishwarya,
Present, ma'am.
Amrish,
Yes, ma'am.
Anu,
Present, ma'am.
Arbaz, Arjun,
Present, ma'am.
Ashok,
Present, ma'am.
Benita,
Present, ma'am.
Bhargavi,
Yes, ma'am.
Bhavishya,
Present, ma'am.
Chaitra,
Present, ma'am.
Devmalai,
Present, ma'am.
Diksha,
Present, ma'am.
Deepika LG,
Present, ma'am.
Deepika MB,
Present, ma'am.
Murli Krishna,
Present, ma'am.
Gangubai,
Present, ma'am.
Gujiya,
Present, ma'am.
Arshit,
Present, ma'am.
Junjar,
Present, ma'am.
Kavya,
Present, ma'am.
Kishore, Kishore, Lata,
Yes, ma'am.
Manisha,
Yes, ma'am.
Manjunath, Nayana,
Yes, ma'am.
Nilanjan,
Ma'am.
Nishant.
Present, ma'am.
Since from long time, where were you, Nishant?
Ma'am, sister marriage, ma'am.
For sister marriage, you have not attended so many classes. Huh? Pavitra,
Present, ma'am.
Maithili,
Present, ma'am.
Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash,
Present, ma'am.
Rajeshwari,
Present, ma'am.
Rakesh,
Present, ma'am.
Ramya,
Present, ma'am.
Rashmi,
Present, ma'am.
Ravi,
Ma'am.
Rizwan,
Present, ma'am.
Vishal, Savita,
Yes, ma'am.
Shruti,
Present, ma'am.
Sneha,
Yes, ma'am.
Spurti,
Present, ma'am.
Srinidhi, Srinivas.
Srinidhi, present, ma'am.
Okay. Sunil,
Present.
yeah,
Present, ma'am.
marked. Sunil,
Present, ma'am.
Vaishnavi,
Present, ma'am. Present, ma'am.
Vinny.
Present, ma'am.
Yeah. Hope so. You people have executed 5th program, and tomorrow you have to show me the 5th program. Yes. Any doubts regarding that? 5th program you have to complete. I have posted your 5th program even in your